Hello friends, welcome to our channel. Today we will discuss regarding on that is application of three-state buffer or a tri-state buffer in BOS system. Okay, using decoder. That means using three-state buffer and decoder instead of a multiplexers. Previously, we have already designed BOS structure with the help of registers and multiplexers. Here, instead of a multiplexers, we will consider that is three-state buffer and a decoder instead of a multiplexers to design BOS system. So how we design BOS system using three-state buffer and a decoder instead of a multiplexer, that kind of things we will discuss today. So it is the best application of three-state buffer for BOS system. Okay. So if we go through this three-state buffer, then we have already discussed in a last lecture how to design three-state buffer. I have just remind you, I already discussed that part, how to design three-state buffer. Okay, but the thing that whenever we will design this three-state buffer, then the most important part of that is one is that is whenever receive the data, okay, from that is control system like this. Here just remind it. I just show you how it is a three-state buffer we will consider. We have already designed. You see, one decoder is there who provides some or who control the data to the corresponding inputs, and enable one control unit is there, enable. If it is 1, then this particular decoder provide the data or activate to the corresponding three-state buffer, and based on that this buffer receive the data from these inputs where enable is 1. Okay, if enable is 0, so total this decoder is inactive. It is also inactive to the particular buffer, and there is no output because it is open circuit. It will be open circuit whenever we go through there is a disable, or E is equal to 0 means a disable. Okay, this kind of a basic concept we have already discussed in last class, and another concept it is defined through selectors. Two selectors are there, one is S0, another is S1. This will decide which buffer need to receive data from the corresponding inputs. Okay, these inputs, how data corresponding inputs, how input data pass to the corresponding buffer or three-state buffer, it will decide by this two selectors through this decoder. These kind of things we have already discussed in last lectures. Now we discuss how this three-state buffer or how three-state buffer apply for BOS system, okay, with that kind of a decoder concept instead of a multiplexers. Previously one structure is there, one design is there, that is using register and multiplexers we have already discussed. Okay, we have already designed also. Now I will apply the three-state buffer with decoder instead of multiplexers. How it will design, we will see that. I also that is consider that that is a design. Now we see very simple way I design here. Now one part I will explain how these buffers and decoders and registers, the all things is combined to make that BOS system or common BOS structure. Okay, where same concept, but instead of a multiplexers we will consider that is decoder and registers. Okay, you see, let us consider that is a 4 register. See, very simple way, 4 register, that is register A, register B, another register C and D we can consider. Here I didn't mention here because it is not so space to design, but similarly what we have already designed for register A and register B, similarly we can design register C, register D, no problem. Okay, and each register connected to this, that is a 4 inputs. You see, very simple way, that is 0, 1, 2, 3, that is A register. Similarly, register B 0, 1, 2, 3, like this. Okay, and it is the input from register. Okay, each individual register, either A, B, C, D, doesn't matter. That means whenever the data pass to this individual buffer, you see here is the 3-state buffer. One state received from register data, another, you see, whenever it will release the data, that data pass to this common bus. You see, common bus, each individual, you see, the data is mentioned, that is 0, 1, 2, 3, that data provided by register A. We can tell as A0, A1, A2, A3. Similarly, B0, B1, B2, B3. Similarly, C, D register also provide such kind of a corresponding data. But if it connected to this individual buffer, 3-state buffer, then another control line or control input also design or also will consider through this decoder. You see, this particular decoder contains 0, 1, 2, 3. It will consider in this way. Okay, this particular you see 0 connected to this particular this A. Okay, that means whenever that is, we will consider, that is last time, that is with multiplexers, that multiplexers and registers in that design, S0 and S1 also decide which register data provide to the common bus. That depend on the S0 and S1. Similarly, here also it is defined. You see, S0, S1 also decide this data 0, 1, 2, 3 for individual register. You see, here 0 means connect to this register A. Okay, you see, the connect to the register A with different 3-state circuit. You see, they connect to the different control unit or control input, connect to this individual circuits. Here circuit, it is also another, here another, here another. That means A0, A1, A2, A3 data whenever provide to this 3-state circuit, whenever this data, this control unit or control input connected to this with active mode, then it will data receive from register A and pass to this common bus. You see, pass to this common bus. Okay, similarly, very simply, you see this one connected. This is for A, which is activated by 0, and 0 is also activated by S0 and S1. Okay, that is also, we can also define very simple way. Suppose S0, S1 and S0, it is we can also find out here very simple way. We have already discussed that kind of a concept also previously. We can also output, we can also define in this way. Okay, very simple way. The like a 0, 0, that is 0, 0, 1, that is a 1, 1, 0. Okay, 1, 0, that is 2, 1, 1, that is 3. Okay, in this way also we define, that is 0, 0 means 0, this value will be considered. 0, 1, 1, this value will be considered. 0, 1, 0, 2, 2 value will be considered. 1, 1, 3 value will be considered. That means which register it will decide by this 0, 1, 2, 3. That means 0 means 0, 0 that is decide for register A. That means we can write for this particular this one, that is register A. Okay, that is for register A. 1 for register B. Okay, and another, that is 2 register C. Okay, and another similarly if we go through that is 3 register D. Okay, A, B, C, D, 4 register, it will decide by this S0 and S1. These two selectors, it will decide which register pass their inputs to the corresponding outputs to the 4 line common bus. It will be decided by this decoder. Okay, and this decoder also, another concept also there. You see, very simple way it is mentioned, like it has also enable E also enable here. Okay, if E is equal to 1, E having two data, E is equal to 1, another is E is equal to 0. If E is equal to 1, that means enable. If enable, definitely it will choose either 0 and 1. Either 0, S0 and S1, it will select either 0 or 1, 2, 3, it will be decided by this S0 and S1. Okay. If E is equal to 0, total decoder will be inactive. That inactive also, that inactive to this register A or register A, register B, whatever things, it will be inactive. Total system will be inactive. So, whatever the data provided by this register to this particular buffer, there cannot be pass or cannot be considered as a input to this particular buffer, by which the data will pass. There is no output to this particular 4 line common bus. Okay, if E is equal to 0, if E is equal to 1, then it will be activated, decoder will be activated, it will decide, that is S0 is what value, S1 is what value. Based on that, it will consider 0 or 1 or 2 or 3. Okay, for example, S0, for example, S1, S0, suppose here is 1 and 0. That means which value? The 2 value. 2 value means here, 2 means what? That is what? C data. Okay, C register. So, it activated C register. Okay, C register also constructed by this kind of a figure. Again, C register also provide this individual data to this common bus, and in that case it will be activated, there is no problem. Where E is equal to 1, then it will be activated this decoder. This will be defined which register will be activated. So, either A, B, C, D, any kind of a register will be activated by 0 or 1 or 2 or 3. Because I have already mentioned 0 for A, 1 for B, 2 for C, 3 for D. So, automatically corresponding register will be activated and provide the data to the 3-state buffer, and that 3-state buffer will also release the corresponding data as per this value. A0, suppose A register will be activated, A0, A1, A2, A3. Similarly, if B register activated, when B register will be activated, that is 0, 1, this one, B will be activated by 1, this one. Okay, so B0, B1, B2, B3 data will pass to this 3-state buffer, and that data pass to this common bus. In this way, what happens? Instead of multiplexers, we will also consider 3-state buffer as well as register as well as decoder. It is very convenient to find out which register, okay, which register that is provide the inputs to the different 3-state buffer, by which they will provide to the provide the data to the 4-line common bus. This data sometimes consider as input to the any kind of a register. That kind of a concept also there. As the previous concept, whenever we will apply multiplexer, okay, that concept also we can apply whenever it is necessary. This 4-line common bus also consider as a input to the corresponding register. That is also we can define. Okay, depend on that what type of question we will consider, based on what kind of problems we consider. Based on that, we can collect the data from this 4-line common bus. Again, that data consider as a, these are the output data. This output data that is consider as a input data in which register we will decide based on these questions. Okay, so that kind of a concept also we can apply. Okay, so thank you very much to watch these videos. If you like these videos and like this channel, please comment to me and please subscribe my channel. I also improve these videos and progress our channel. So thank you very much. Thank you very much to all. Thanks to friends that is to watch my videos and also use my channel. Thanks to all. Thanks to all and to see this video. Thanks.